In this video we'd like to talk about the half equivalence, and this is a method that we'd use to work out Ka. So hopefully you can see there I've drawn a titration curve. This is for a weak acid with a strong alkali, and there we've got the equation written out. So I'm just talking about the acid HA with sodium hydroxide. So if we look at this equation a little bit more and think about what the curve represents, so the point at which this reaction is all over is there. So that's when this reaction is finished and we have no acid left. This is the equivalence point, and on the graph I'm going to call that point X. So if we just focus on this part of the graph again, from 0 to X, let's have a look at what happens along the way. So we have this sequential decay of the acid. So at the start we have 100% acid, and at the end, when we've reached X, all of that acid has turned into the salt, which we can call A-. So X is the equivalence point, so obviously the half equivalence point is halfway through this reaction, which we'll call X over 2. So can you see anything special at the point where we've got the half equivalence point, X over 2? Well, we're halfway through the titration, half of the acid has gone, and at that point the amount of acid that we've got is exactly the same as the amount of salt that we've got. Obviously you wouldn't see this when you were doing the titration, but you could draw the curve and then go back to the curve and have a look at what you've got at half equivalence point at X over 2. So what's special about this half equivalence point? Well, if we refer to the Ka expression, for a weak acid, we probably remember that we've written this out many times before, and at the half equivalence point, if the amount of acid is the same as the amount of A-, then they will cancel out. So at the half equivalence point, Ka is equal to the concentration of the hydrogen ions. So at that point, if you use the graph, you can work out the pH at that point, and you can now do one of two things. You can say that if you know the pH, you can convert that into the hydrogen ion concentration. Remember, hydrogen ion concentration is 10 to the minus pH, and that will tell you the Ka. Or, since the conversion between pH and hydrogen ions and pKa and Ka is the same, at this point pH is equal to the pKa of the acid.